This is a tutorial about how to use the mass and the velocity of an object to calculate force. In this particular situation, it's a 70 kilogram person traveling in a car going about 13 meters per second, which is about 29 miles per hour, a very typical speed for driving on the streets. If this person isn't wearing a seatbelt and doesn't have an airbag, then the windshield is going to be applying the stopping force. The stopping distance of a windshield is about 3 centimeters, but since we're dealing with newtons and forces in newtons, we want to go ahead and convert that to meters. So 3 centimeters is converted to 0.030 meters. Just move the decimal over 2 places. So the question is, how much force would be applied to the person's skull? It's a two-part problem, so we're going to go through 3 screens. The first part of the problem is we've got to figure out what the person's kinetic energy is. Until we know that, we really can't go much further. So I've broken this down into that part only. A 70 kilogram person is traveling in a car going 13 meters per second, approximately 29 miles per hour. What is the person's kinetic energy? So what we know is the mass of the person, 70.0 kilograms, and we know that the car is traveling a velocity of 13 meters per second. And the question is, what is the person's kinetic energy? So that's our unknown. This is a pretty straightforward problem. We're looking for KE, and we have a formula for kinetic energy, and that is 1/2 the mass times the velocity squared. So we come over here and we plug in what we know. KE equals 1/2 the mass, which is 70.0 kilograms, and the velocity 13 meters squared, or meters per second, and then the whole thing squared. So from here, it's using your calculator. 13 squared is 169, and then it's meters squared and seconds squared. And we're going to multiply that times half of 70, which would be 35.0 kilograms. And 35 times 169 is 5,915, and it's a kilogram meter squared per second squared, which we know to be a joule, or a Newton meter. And that's the first part of the problem. So we're going to use this on the next screen, so keep that in mind. The energy of the person is 5,915 joules. So we come over here, and now we've got the second part, and in the end what we're looking for is how much force would be applied to the person's skull. So we know we're looking for force. Now we know that the kinetic energy of the person from the screen before is 5,915 joules. Okay. We also know, if that's the kinetic energy of the person, that that's going to be the work done to stop the person. So we'll go ahead and write that down just to remind ourselves of that relationship. So the person crashes into the windshield. The stopping distance would be about 0.30 meters. So our distance is 0.03 meters. So now, looking at what I'm given and looking at what I'm trying to find, force, I see that I can use the work formula here. Work equals force times distance. So work equals force times distance. The work done is going to be 5,915 joules, and that's going to equal a force, which is unknown, times distance, 0.03 meters. Now, to be able to solve this problem, I'm going to have to isolate F. I'm going to have to get F by itself. So right now, F is being multiplied by 0.03. So I'm going to need to divide both sides by 0.03 meters. That's going to cancel, leaving me just F on that side. And then I get out my calculator. And 5915 divided by 0.03 equals a very large number, 19716, and then it's 6.6. So I'm going to go ahead and just round that to the whole number, 197167. And then this is a joule, which is a Newton meter. So meters cancel, leaving me with newtons as my unit of force. Quite a bit of force being applied to the person's skull.